Thank you all for coming. Thank you to Cloudera for hosting us. We are in person again and quite happy to be that way, and thank them for the food and drinks, the refreshments. So thank you very much, Cloudera. And I think that's all I'm going to say this time, and I'm going to turn it over to Sid from Cloudera.
Thank you, Guy. Hey, good evening, everybody. My name is Sid Sheikh. I'm the head of products for our containerized database services at Cloudera. We are the world's largest database vendor in the on-prem space for databases. We are very privileged to host this amazing meetup in the confluence of Apache and CNCF projects. So we are blazing the trail here. Super happy and honored to be hosting this. We hope you enjoy this session and you learn a lot and you can take some inspiration back to your workplace. Thank you. With that, I'll hand it over to Anusha to kick off our first talk.
Hi, everyone. How's everyone doing? Got your pizzas? Yeah, they look good. I didn't want to pig out before my talk. This is my first Bay Lisa meetup. So thank you, Guy, for organizing. And I'll be sure to be plugged in Bay Lisa going forward. My name is Anusha Raghunathan, and I'm a principal software engineer at Intuit. And this evening, I'm going to be talking about how we built a scalable, reliable, Kubernetes-based platform at Intuit. And a little bit about me, I've been at Intuit about 3 years. Prior to that, I worked for several years at Docker, the container company, and also at VMware. And I mainly worked on teams that built products and services for end user companies. And that was pretty exciting. Then I joined Intuit and I realized that being an end user to all of the amazing tech stack is even more exciting. And I've been having a fantastic ride here. Having said that, here is the agenda for the day. I'm going to give a background of what Intuit does and a little bit about our infrastructure, and specifically focus on the Kubernetes-based platform that we've built and the different personas that it serves. Then we'll deep dive into what a single Kubernetes cluster looks like, and also what are multi-cluster management tools that we've built. Then we'll jump into GitOps. GitOps is big at Intuit. We'll dig into that. We'll understand why it's big at Intuit, hint, Argo. And then we'll take a small use case, not so small, actually. It's a use case where we use GitOps for keeping our clusters up to date and doing a progressive delivery of all of the features that are required for our fleet. And we'll dive a little bit into application abstraction. This is the future that we are working on. Our platform is evolving from a very Kubernetes-centric platform to a more abstracted platform to reduce the cognitive load for our developers, and finish up with some takeaways. So hopefully you guys are familiar with this product. Yes, okay, good. Intuit makes it. So Intuit has these 5 flagship products, including QuickBooks, Credit Karma, Mint, Mailchimp, and of course TurboTax. And know that almost all of the services backing these products run on our Kubernetes-based platform infrastructure. And what are the different personas? I assume people in the room already know what Kubernetes is and what container native workloads are. And so if not, can you raise your hand and I can quickly? Okay, perfect. No hands up. So our platform serves 3 different personas. One is the service owner who's responsible for writing their Java code or Node.js or Python code. And the service owners are purely responsible for writing financial services related code. So they are not worried too much about the infrastructure. They're not worried about how things work behind in the cloud. They are purely interested only in writing their Java code. And one of the priorities for a service owner is to accelerate their development velocity. And the reason why this is important is so that they can have a faster inner development loop of code, build, test, rinse, and repeat, so that they can actually deploy the latest and greatest features and go to market so that they can provide a product differentiation based on that. So agility is key for these service owners. The second persona we cater to is folks we call a platform-on-platform engineer. So these are platform teams that use Kubernetes to build very unique, specific use cases and serve the rest of Intuit developers. For example, the CI platform runs on Kubernetes. The Argos CD clusters run on Kubernetes. ML, stream processing, batch processing, all of these run on our Kubernetes platform. And then finally, the Kubernetes platform engineer, that's people like me and my teams. And the Kubernetes platform engineer's main agenda is to support these other two personas and for whatever use cases there may be. And we typically take care of building single node Kubernetes clusters and whatever features that are needed to keep it scalable, securable, as well as if it supports any feature set that is required by our service owners, then we provide that as well. We also are responsible for our multi-cluster management software. So we run a pretty huge fleet of Kubernetes clusters, and we have written software around management of those clusters, not just clusters, namespaces, instance groups, and all of the primitives around the Kubernetes platform. And we're also responsible for managing and operating the fleet. You build it, you operate it. So let's look at some numbers. So this platform actually supports about 900 plus development teams, roughly about 7,000 plus developers, all of them within Intuit. This is about 2,500 services, and these are just production services. They don't include pre-prod services that are used for validating their service code, their scale, their performance, and so on. This is just production services. And we support about 310 plus clusters. It keeps growing. And that's backing about 27,000 Kubernetes namespaces. Now, folks who are familiar with namespaces, Kubernetes namespaces might know that namespaces are the basic primitive that provides isolation in Kubernetes. So a service running in one namespace doesn't talk to a service running in other namespace unless there are some networking mechanisms that are and policies that are enforced to allow that. So you get an automatic isolation in that regard. There is another way we do isolation for our workloads, and that's using instance groups. Instance groups are concepts where you have a node, and these instances are basically carved out only for you as a service owner, and it's not shared with anybody else. So basically, with namespaces and instance groups, we are able to achieve multi-tenancy. Now let's look at how a service owner's workflow operates. Here's our service owner. She codes, builds, and tests. And that's pretty much her responsibility. Now, when it comes to deployment, that's under what we call operations. And monitoring happens. If something goes wrong, they get alerted, and then they basically look into what's going on. Their on-call typically looks at it. Now, let's look more into the interesting deployment phase of this pipeline. So when a service is ready to be deployed, there is a controller that actually makes the initial placement of the service in a particular namespace, in a particular cluster. And this initial placement is made using several factors, including where the service persona, which BU the service persona, the end user business unit that this persona belongs to, so that they can go to their set of clusters. But what is the capacity of the clusters? Do we have any room as far as packing more namespaces in a particular cluster? Whether we have enough number of IPs available depending on the CIDR blocks and so on. And then also the environment. We have clusters that are in pre-prod and clusters that are in prod, and they are dedicated clusters. We don't mix and match. Pre-prod and prod workloads don't run together. Same thing with region as well. We have several regions for HA and DR. And so depending on what the service persona's characteristics are, the initial placement of that service is made on a Kubernetes namespace in the right Kubernetes cluster. So I spoke a bit about that already. One of the things that we do provide out of the box, once the service is placed in a namespace, is we have out of support logging, monitoring. Logging is using FluentD. Monitoring is using Wavefront. It's a VMware product. Security and compliance is using several tools, including Falco and OPA. Observability, logging, metrics, and traces. For traces, we use OpenTelemetry. And then for networking, we actually have ALB-based north-south traffic. And for east-west traffic, we have service mesh, EastU. And then storage, we have our cloud-based storage provider. And then reliability testing is using Chaos. So having said that, let's look at what our fleet looks like. This is a single Kubernetes cluster. Now, one thing to point out right away is, so maybe quiz time. What is missing in this picture for those who know Kubernetes? Is this truly representative of a Kubernetes cluster? No volume. Yes, that's there too. Where is the control plane? This is only a worker node. There is no control plane. Kubernetes control plane with API server, controller, etcd, all that is missing, right? That's because we don't manage the control plane. It's in our cloud. Amazon is our cloud. We use EKS. So our control plane is managed by Amazon. One less thing to worry about. And we manage the worker nodes. So in the worker node, the app, the service that we just deployed landed up in one of these green boxes. And that's the app namespace. And when you look at the nodes down below, you have several nodes there in the blue boxes. And notice that these services are actually running as pods. And each of the services are backed by HPA. The orange box there is the HPA or horizontal pod autoscaler. So depending on your services parameters, whether it's traffic, CPU, or memory consumption, you can tune your HPA to look at different metrics and scale your services automatically. So that's a pretty important, critical feature, especially when you're looking for high scale. And all of these services are exposed via Kubernetes endpoints with an ingress object that backs it. And that eventually is a target for an ELB that's running in the cloud. And it's discoverable using a cloud-based DNS service. We use Route 53. So that's how the service discoverability happens. And the other thing to point out is we install about 30 plus add-ons, cluster add-ons, once the worker nodes are up for various different reasons, for logging, for observability, logging, monitoring, tracing, security and compliance, for scale, for all of these enterprise readiness, day one, day two needs. So some of them are core DNS for, of course, your DNS needs, cluster autoscaler for basically scaling your nodes out, KAM for authentication with the cloud, ALB ingress controller for ingress traffic. So this is one Kubernetes cluster. So how many clusters, first time again, how many clusters do we manage, ballpark? Oh my God, yes, t-shirts for all of you from Melotl. Yes, 312. And So that's a lot of clusters. And when Intuit actually migrated to using the Kubernetes platform back in 2018, there were not very many tools to provide multi-cluster Kubernetes management. In fact, there was no such thing called SIG cluster lifecycle. It's actually a thing right now, but it was not a thing back then. And there were not very many startups in this space, and even cloud providers, even EKS was not there. They were still doing ECS. So basically, we had to build our own. So we have our own, long story short, we have our own multi-cluster management tooling, and it's called IKSM, Intuit Kubernetes Service Manager. It's not open source, but just for the purpose of this talk, I'm just using it as IKSM because that's what we call it internally. And IKSM actually provides a centralized management for everything Kubernetes, whether it's clusters, namespaces, alerts, monitoring, instance group management, and so on. And IKSM actually provides lifecycle, basically all of the CRUD operations, the create, update, and delete lifecycle operations on the clusters and namespaces. And note that, especially for clusters, we don't do create and delete as much as we do upgrades. And I will get to that in a bit. And IKSM exposes a rich set of REST APIs so that the entire multi-cluster functionality can be extended by the platform teams, or can also be called by other clients of IKSM. And we'll also go through one of the use cases. Monitoring and alerting, it provides real-time monitoring and alerting because it has real-time information about the clusters and namespaces. So when it's the end user developers or DevOps, they get alerts for their namespaces. When it's platform engineers like me, and then I go on call, I get alerts for all of the clusters and cluster health. And security and compliance, every operation for all of the clusters is actually logged and audited through IKSM. So it's like the single funnel that you can use to audit the operations. And this helps with regulatory and compliance needs for Intuit. The other way we provide security with IKSM is that every vended cluster and namespace is vended out in a customized way that we know have the right guardrails. So for example, namespaces will, you cannot have extreme resource limits or namespace quotas or policies, networking policies where you breach and you can talk to another namespace. So all of these are controlled, and there is what we vend out is very secure and makes sure that we don't blow up clusters or we blow up multi-tenancy. This is a simplified architecture. So we provide a UI and CLI on top of the REST APIs. And IKSM is actually a microservice running on a Kubernetes cluster that we manage. It's also yet another microservice. And we have 3 pods for availability, and one of it is the leader, the other 2 are slaves. And the actual work of doing the lifecycle operations are done by the IKSM worker pods in the light blue. The interesting thing about this specific cluster is it runs the Argo CD controller as well, and we'll talk about why, hint GitOps. And we have replication in S3 cross-region replication for the data for all of the artifacts that are being managed. And it runs in 2 regions, in active, passive. Now, IKSM actually serves all of the 3 personas. We started out our talk with the service persona, platform on platform, as well as the platform engineer. And that's how powerful this multi-cluster management is. And if you're trying to build multi-cluster management tools, this is the right place to actually serve all of these personas if you have to deal with a variety of use cases. Now, let's look at our use case. And that's when we get into GitOps. All right. So this is 2023. I had to do something with Gen AI. So I did this. I asked Gen AI about what is GitOps. So it gave me a beautiful answer. So it's the software development methodology that uses Git as the single source of truth for defining and managing infrastructure as well as your application deployments. In this specific case, we're going to talk about managing infrastructure. Now, let's talk about clusters and their life cycle. So the way we treat clusters at Intuit is they are actually pets, right? Like we create a cluster, we take care of it, we're not throwing them away. Once you create it, unless there is a really important need, you're not decommissioning it, or unless it's out of capacity, then you create another cluster. But we do take good care of our clusters. So they're like pets. And so creation happens once, deletion happens once, but upgrades, on the other hand, they are continuous. And here is why. Intuit is a financial institution, and we have very strict compliance and regulatory needs. There are a lot of those on the data side, but one important one on the compute side is that we have to rotate our nodes out every 30 days to stick with compliance. Because the most straightforward reason for that is that if your AMIs, if your images had some CVE that was out in the open, there is a chance that you could get hacked. So we have to rotate out our AMIs every 30 days, or we actually go out of compliance. Now, imagine doing that for 315 clusters, each with roughly about 50 nodes, right? You don't want to do this manually. You need to be smart about how you orchestrate this cluster upgrade process. And that's when we started looking into GitOps. So how many people are familiar with Argo? Oh, nice, half the room. So a small piece of information, Intuit incubated Argo. And it started with Argo workflows and then went to Argo CD, and now we have Argo events and a whole bunch of other Argo projects. The one that we are talking about here is Argo CD, which is basically a progressive delivery mechanism. You have an artifact, it can be a service image that needs to be deployed, or it can be a cluster configuration that needs to be deployed, or anywhere in between. We use it for alerts, we use it for AWS configurations. So we use it for a variety of reasons, but it's basically progressive delivery of an artifact that gets deployed into your environments. So in this case, as you can see, we are having the 300 plus clusters, the configurations stored in a GitHub repo. This is a snapshot of the GitHub repo showing clusters in pre-prod US West. And the way this is organized is using customized bases and overlays. Are people familiar with customized bases and overlays? Okay. It's pretty straightforward concept. So the way it works is you have, let's say you have 100 different configurations, and but they're not radically different. They're just a little bit different from each other. So what you do is you gather up all of the commonality and put it in a base, and then you have overlays, which are these leaf nodes that carry the configuration that is different from the base. So then there is a tool that's native to Kubernetes. It's called Customize, that basically looks at the bases, looks at the overlays, does a bunch of patch merges and magic, and then applies it, right? But as somebody who's maintaining this, it's pretty straightforward for you, because you can look at a base, you can look at an overlay, you can determine what the configuration is going to be. So we use Customize for our configurations. And here is a sample cluster config, right? You can see that this is of kind cluster, right? There is no kind cluster that's native to Kubernetes. Yes? So this is a CR. It's a custom resource. Basically, it's an extension of what is not native. So we use a custom controller to define and handle the cluster CR. And you can see that the spec, this is just a very small portion of the spec, but basically the spec contains all of the cluster add-ons, what are the different parameters, and so on and so forth. Now, with how do we do cluster GitOps? In other words, how do we do these monthly cluster upgrades every 30 days without ruining our brains? So we use Argo CD plus Kubernetes controllers and IKSM to drive this. So I'm going to walk you through what happens. So the GitHub repo that we just saw, we raise PRs. Let's say we have to update the AMIs, and every AMI is for a region. So we'll get 3 different AMIs from AWS, and those need to be rolled out. So we'll create 3 different PRs, one for US West, one for US East, one for AP Southeast. So let's say that the US West PR just got merged. We have an Argo CD server that's listening in for the changes. It pulls in the changes. Then it actually tries to sync with the cluster config CRD that's in this. They have a cluster that's running just this processing. And then it sends an update event to the cluster config controller. Now, the controller is the one that's actually reconciling with this configuration change. The controller basically looks at its current state and its desired state and sees if there is a difference, if there is a drift. If there is a drift, it tries to reconcile and apply that new diff onto its existing state. And then it actually triggers, let's say there was a diff, then it triggers an update operation. And that's when it uses the IKSM APIs and says, hey, go do a cluster upgrade. IKSM does the cluster upgrade. It sends the operations response, which gets returned back from the controller to the CRD. So if those of you who have used Argo CD UI, you can actually go to the UI, look at the status and so on. But from the GitHub PR perspective, the PR is done at some point in time, everything gets reconciled. You can use the IKSM UI to see if there are any errors. If there are any errors, actually we send out alerts to person on call and you will know whether something went wrong or not. So that's, again, very high level of how we use GitOps, Argo CD, IKSM, extended Kubernetes controllers to pull together this monthly cluster upgrade dance. All right, last part of my talk, application abstraction. Now, we had our developer doing the code, build, test, deploy, monitor, like we did before. Note that in the deploy phase, they are also using a GitOps-based deployment configuration. And if you look at the configuration files for this, they're not very friendly. They're basically worrying about how do I set my scaling min replicas and max replicas, because the deployment is containing way too much Kubernetes information. It's a leaky abstraction. In fact, what we went out to our using kubectl, we are actually giving that to the end users. So that's just too much Kubernetes for them. And they are Java developers who want to worry about Java coding. They have to worry about whether 15-second health check interval for my ALB is sufficient or not. How do they configure my max unavailable for pod disruption budgets? What are good CPU memory limits? What should I use for my resource quota? Even if we vend out some standard values, there is always this confusion about, hey, is what they vended out good enough, or do I have to go tweak it? Right? So this is a huge cognitive overload for developers to understand and manage Kubernetes. And anyone who has worked with Kubernetes knows about these notorious API deprecations. Yeah, I see heads nodding. Yes. So every three releases, the community decides to, that's actually the policies. You can have an API deprecated every 3 releases, but they do have replacement APIs for it, but you still have to deal with it. You still have to make changes as a platform team. So quick example, Ingress v1 beta 1 works well in Kubernetes 121, breaks in 122. So what do you do as a platform team? You scan all of the repos, the GitOps repos that are having the v1 beta 1, and then you contact the service owners, and then you migrate them, or you write tools around it, but it's still not pretty straightforward. You have to make sure that you don't break anything in along the way. So deprecations are painful in Kubernetes, API deprecations. And the final problem that we're seeing is, although the application developers has configuration related input, they don't have operational input. The Kubernetes doesn't tell you if I can enable HA or how do I enable DR. Or say, for example, I want my services to accept some services to accept external traffic, but some to not accept external traffic. They're probably just east-west. How are you going to specify that, right? So it's all of the operational needs of the service are not specified in any of these Kubernetes YAMLs. So looking very deeply at all of these problems, we are currently building an application abstraction platform where we are not exposing Kubernetes like before directly to the end developers. We're exposing a more abstracted platform to end developers. So the desired target state would be something like application developers come in, specify their intent, and this question mark is the abstraction software. And then that does the magic of doing whatever is needed, whether it's a compute abstraction, network abstraction, whether it's taking operational needs, so on and so forth, and then deploying it to a Kubernetes namespace. Takeaways. 3 things. Multi-cluster management is hard, especially when you have to deal with scale and then throw in some stateful sets and throw in some data. It's hard. So if you're trying to do something like this to start with, then look in existing OSS projects, pour into some end user case studies, because there are people that have done it already, so that you can cross-pollinate the design and implementation strategies. Do you build in-house? Do you buy from a vendor, or do you just go open source? This is a very dense, it's a packed bullet item. And the reason is because it's got so many subjective factors that you have to look into. So if you were going to build in-house, like what we did at Intuit, and we didn't build everything in-house. Like I said, the control plane is a managed control plane. We have some observability tools that are completely from vendors and so on. But we did build a lot, and then we did use open source. But we have a dedicated team, and that team is big. So look in your own organizations and see if you have the resources and the skill set to make the investment. Another thing with open source is that there is so much fragmentation in the cloud native world that even for like one small vertical, there are at least 5 different projects. So you need to understand and evaluate which open source solution you need to do. You need to go with. There is always a paradox of choice in the open source world, especially in CNCF these days. So you have to basically do your due diligence and make sure that you can work with that ecosystem going forward. And then Intuit is big in open source. So we have Argo. And then we also have a couple of very interesting projects. One is NumaProj. NumaProj is all about data analytics. So you get a stream of data, you process it, and then you can also apply AI ops on top of it. So all of that is open source, and do check it out. And then there is KeikoProj, which is heavily used in the multi-cluster and the single cluster projects that I was talking about. Take a look at that, and that's our LinkedIn OSS link. I spoke to my marketing lady right before this talk, and she said that I needed to plug that in. So there you go. Follow us there. You will get updates on our open source strategies and our projects. And with that, thank you very much. Questions?
Thanks so much, Anusha. That was really awesome. You can catch Anusha at the end of the sessions as well. If anybody have any questions.
So I'm curious, how did you get learning the Kubernetes and get certified and all that. That's very advanced than most of Kubernetes engineer I have known. Thank you.
I worked for a container company called Docker, and I had no choice but to learn. Yeah, but if you're looking to learn, there are a lot of certification options, and they take you through the motion of introducing the concepts, providing hands-on labs. I know that GKE even has a online playground where they back it up with a bunch of Kubernetes clusters, so you don't have to install Kubernetes anywhere, or you don't need a cloud account. GKE, the Google Kubernetes engine, provides free playground if you're getting started. Yeah, so look in all the, like, if it's AWS or GKE, they want your workload, so they're going to give you free training and all that. So I'd say go look there.
How do you test IKS and for API applications that you were talking about? Do you catch them in pre-production environments if they break, or do you catch those API deprecation problems in production environments in case you miss things? That's one question.
I don't think I heard the full question, but the first question was, how do you test IKSM? Okay, and the second question, can you mind?
It's part of the whole testing strategy. I'm wondering, when you do upgrades, if there are breakages, how do you catch them? My second question is more organizational. How big is your team?
Oh, okay, sure. So testing, we are a very agile company, and by that we have one sprint is 2 weeks. I think that's pretty standard across the board. And in there, all of our PRs have to have unit tests and what we call BDDs, behavior-driven. I don't know what the D is, but it's some sort of behavior-driven testing. And we rely heavily on our BDD suite of tests. And there are tests that run as part of there are several tests that run as part of your PR. Then we have nightly tests. Then we have data tests. Then we have add-ons, like the add-ons. Because add-ons, we don't manage all of the add-ons. We are the core team, but the add-ons are contributed from across the ecosystem. So all of the add-ons keep running. So it's a constant CI and BDDs that keep, and we don't make a release unless the BDDs have been green for several days, right? So going in, we know that there is some level of confidence about the release, but that doesn't mean that it's perfect. In fact, there are all these corner cases, and not all workloads on all clusters are the same, right? So, so what we do is then we have something called dog food clusters, and these dog food clusters are clusters that are not end user clusters, because we don't want to mess with the TurboTax cluster. We're going to get a call from Sasan, who's our CEO, right? So we don't do that. So, but we do have very friendly clusters that are in our sister teams that we use. For example, Argo CD is one of our dog food clusters. And yes, what is the worst that can happen when Argo CD is non-functional? Your new deployments won't go through, but it's still not going to cause an end customer outage. But we have some sample dog food clusters that we are constantly using to verify the release. We also have a E2E platform. So what we do is we have RC builds that run on our E2E platform, and we have a bunch of clusters there as well, different workloads. And we make sure that E2E is fine. Then we do dog food. Then we do a wave of, only when these two pass, then we move to production clusters, pre-prod clusters, and then prod. So we do it in waves. So that's why the cluster upgrade cycle is long. But since it's automated, it's just a PR. So yes, but then we have on call. So whoever is on call goes on to service those alerts, and if it is causing an incident, then we go from there. How big is our organization? It's actually hundreds and hundreds of us. I think it's about the whole developer experience or developer productivity, which includes UI and chaos testing and like a whole bunch of things. I think it's roughly about 500 people. Yeah. Thank you.
So I think it was a follow-on to a question that he had, which was GitOps for cluster upgrades helps in the automation of the triggering of process, right? But once the upgrades is in progress, right? How has your experience been with respect to the amount of toil involved in identification of failures?
So there are alerts for example, let's take a standard cluster upgrade time. We know for a fact that the average time shouldn't be more than, let's say, 4 hours for this particular cluster. If it's stuck in upgrading for a lot longer, you get an alert. So we have alerts on different aspects of the upgrade process. And again, our on-call engineers look at it and I resolve it. And we're constantly, this is a constant improvement, right? So sometimes there are alerts that are duplicates. Sometimes there are alerts that are false positives. Sometimes they are not good signals. So we are constantly working on it, but we have alerts for every step of the upgrade process. Is it stuck in initialization for too long? Is it looping forever? That happens in something is reconciling forever. That is something. Then you basically go look at. So we have alerts. Basically, we rely heavily on our alerting mechanism and constantly improving. We have weekly, bi-weekly meetings to look at all the alerts, and then that's a separate team, but still it's part of the bigger org. Yeah. Thank you.
Any other questions for Anusha? That's awesome. Thanks so much, Anusha.
All right. Thank you, everyone.
Our next speakers are Chris Davis and Rahul Buttisagar from Cloudera. Thanks so much, you all, for sharing.
Check. Oh, it's too loud? It's okay? All right. So yeah, first of all, thanks to Belisa and Madhuri for having us as partners and hosting this talk today at Cloudera. I'm Rahul. I'm an engineering manager on the private cloud control plane team. And I also drive the replication manager charter for the company. I want to give you a brief overview on the use cases that Cloudera tries to solve and provides curated solutions for. So the first one is basically data flow. Enables customers to turn streams into data products by analyzing and identifying patterns into the incoming data and basically come up with actionable intel. For example, fault detection, fraud analysis, etc. Our data engineering provides ETL pipelines to process and curate that data. Warehouses are basically set of data that you can have BI analytics and tools that you can run on to query. For example, how does my revenue look for this quarter? Operational DB provides a very scalable and secure database for structured and unstructured data. And finally, CML, catching up onto the Gen AI theme, is basically a machine learning and AI capabilities workbench for data scientists and data practitioners. So now let me explain how we evolved our architecture from all of this, which was supposed to be monolith, into a much more scalable architecture on Kubernetes. So I want to take a couple of minutes to set the stage. Who over here knows what is Cloudera Manager? Okay, that's good. Okay. Not the folks who are from Cloudera. Come on, if you don't know Cloudera Manager, I need to speak with you. But okay, it's basically an orchestration tool that is used to stand up large-scale traditional Hadoop clusters. So this is a traditional Hadoop cluster. You see the storage is actually shared between the compute and data, right? So Cloudera Manager would basically take commodity hardware, install data services like HDFS. I don't know how many folks have heard of that. But yeah, basically a store for data. And then you would have another set of services that would handle security. For example, Ranger basically controls access control lists, and you would have Atlas for governance for auditing, right? Once you have this, the second section is basically services that do your querying, execute workloads. For example, Hive, many people might have heard of Hive, Impala, and Yarn. Right? So this was the traditional cluster. Now, as we see that more admins and users start using this particular platform, you can see that there's a high chance of getting into a noisy neighbor situation. So what the admins do is they would add more commodity hardware, right? They would do more horizontal scaling, add more hardware, configure more yarn queues, and make sure that the noisy neighbor dies down. But that does not happen because it's just sets the precedence because it's just going to keep on increasing. So this is where we had to do something about it. So generation 2 was where we actually broke the thing, right? It was a two-step evolution. We segregated the traditional cluster into a data layer and a compute layer, right? So for the data layer, this would include services, as I previously mentioned, like HDFS, Ranger, and Atlas, which are basically the data, metadata for security and governance, and would break the workload services, the compute services, into its own bucket called as compute layer. We also migrated this to public cloud so that noisy neighbors, we could keep them on-prem, whereas some of them we could actually execute in public cloud. These would be the transient workloads. But this wasn't enough because customers now wanted a much more flexible and a hybrid solution. They wanted it to be very cost-effective as well. They wanted the same parity that is on public cloud on private cloud. Because in generation 2, we actually modified the way we used to do our use cases as well. We added new data hubs, data lakes, and a completely new experience in public cloud. Now customers on-prem kind of felt left out. They wanted the same experience on private cloud. So what we did was we also consolidated into the same code base. So to summarize, the cluster form factors that we originally had, they were too complex, too labor intensive for really anyone, forgive admins, but anyone to really manage. And for us to scale out, we really needed to re-architect quite a couple of things. So we re-architected the traditional Hadoop cluster from a monolith to a services-based architecture, right? Converted the compute services into microservices for scaling out, migrated and leveraged container cloud to disaggregate data from the workloads. We basically prevented data silos because it's the same storage layer that is being shared across. And then we actually moved to container cloud. And I'll talk a bit more about, and Chris will explain how we did that. With this re-architecture and separation of storage and compute clusters, we ran into a situation where now we can actually upgrade both of them independently. The storage cluster can be untouched, whereas the compute clusters can be upgraded at their own cadence. And like Anusha was saying, for CVs and stuff like that, we do actually run into the situation where we have to provide patches and just for the compute cluster, because those are in a different BU, so those need to be handled separately. So also, we also optimize these applications and how, because CML actually relies a lot on GPU processing. Now, thanks to tails and tolerances, we actually started using nodes that had GPU capabilities with them. Same for data warehousing, because we wanted faster processing, we wanted to reduce the disk latency. So for that, we could use nodes that had SSDs on them. And then independent upgrades I already spoke of. And all of this was actually very easily managed by courtesy of Cloudera Manager and the control plane. So like I mentioned, the Cloudera Manager now gives you the ability to create a Kubernetized cluster, upgrade, refresh it as well. Whereas a control plane or a management console, which we call it, gives you like a single pane interface to create your ML, DW, and all of those workspaces. So I just want to give a quick rundown of what a usual deployment looks like. So you start with bare metals and VMs. Then you install, Cloudera Manager along with the data layer, which we call as private cloud base. As I mentioned, it has HMS, Ranger, Atlas. After this, we install the secret source, which we call it basically ECS, which is the embedded container service. It's a conglomeration of things that we use for storage, for secret storage as well. And once we have that, we install the Cloudera control plane, which actually gives you CRUD apps for deploying machine learning workspaces, DW warehouses. Once we have that, we fetch configurations from the base cluster so that the compute cluster actually knows where and which services to target and execute their queries against. And with that, we can create a CML workspace and be on our way by executing the queries in either Spark or Python. And then we can also add more scaling with virtual warehouses across the globe. So with that, I'm going to hand it over to Chris. You want to share or you want to use this one? Yeah, just press the.
Okay. Hello, everyone.
This is the architect.
So, yes, so I've been with Cloudera for 6 years, been in the Bay Area for more than 20. So worked on a lot of different things, lots of large systems. And so Rahul did a great job going through all the high level stuff. Actually, I like this slide a lot. It's nice in the animation. I'll have to steal that for future. But so now I'm going to get into the dark, gritty parts. What I tell people is I know where the bodies are buried at. I only buried about a quarter of them, not all of them. So I would say that a lot of it of what's because ECS and private cloud is actually the fastest growing part of Cloudera right now. A lot of it has to do with the fact of it's on-premise, air gap, and a lot of our customers, they're financial institutions, they're banks. So pretty much any bank you can think of, they're using one or multiple of our products in the world, not just US, but around the world. And so when you're a bank, you worry about a lot of things in security. So one of the best ways to be secure is to be something like air gap or close to air gap as you can. And so that's why they come to Cloudera for a lot of their database services. So this slide, it's kind of an old slide, but it's still valid. So what happens is, Rahul was describing earlier, after the merger with Hordeworks, we actually migrate a lot of workloads to cloud on Kubernetes. And so what we wound up is something that looks like this. It's still, for the most part, so like this. So what happens to the right-hand side over there? That is the control plane that Cloudera does SRE management of. So there's only a couple of boxes in there, but reality is there's more than 100 different things in that right-hand side. That's the control plane. And that is what customers log into to manage their workloads, deploy, things like that. That's all managed by Cloudera. Then what happens is from there, that launches a workload. The workload then runs in the customer's account. So maybe AWS, maybe Azure, maybe dedicated Google Cloud. But that then has a whole bunch of things running in that as well. So that gets very complicated depending on the particular data service. So this one just so happens to be showing CDW, but you see there's this left-hand side, there's a data lake, which is really storage and Ranger security. And the right-hand side of that is the actual warehouse. And I mean, of course, there's more pieces there, but it's just high level. This is the general architecture that at least a couple of years ago, we started with, that we wanted to bring back on-prem because we want to give a single look and feel for the entire product, whether it's on-prem or in the cloud. So, and you want to share the code, right? So since we had a rule for a while, it's public cloud first, as far as development and deployment, so it's bringing this on-prem and air gap. So this gets pretty tough because of we don't have AWS or hyperscalers. But before I get into that, we should talk about, there's actually two different versions of this private cloud deployment. So we are supporting OpenShift. OpenShift is by far the most popular on-prem cluster. It's a bit pricey, but it is the most popular one out there. So that was our initial offering. We didn't get a lot of adoption because of two reasons. One's price, the other one is complexity. A lot of our customers don't know Kubernetes. I mean, some of them are, how can I put it? I don't want to say they're out of date or ancient. They just have their own specialties, right? They're all smart in their own areas, and they just can't keep up with all these sort of things, right? So, and they don't want this to be their full-time job. They know enough about Kubernetes that they don't want to manage it, right? So it's getting better. Kubernetes, I think, is getting better, but it's still pretty tough. But so that's when we came up with the right-hand side, the ECS, which is resonated a lot with our customers. So what happens is it's the same thing as what we were offering on OpenShift. Remember, OpenShift is what we're trying to replicate what's in the cloud. So the right-hand side there is basically those three on top: control plane, data service. Those are the same. But what's added here is the Kubernetes layer. And instead of the customer managing, that's where Cloudera Manager comes in. So that's our secret sauce there for managing, because customers already know Cloudera Manager. Cloudera Manager is the secret sauce of Cloudera. It's actually in everything, to be quite honest. People have tried to remove it from a number of places, but it's always a problem of what are you going to replace it with, right? So, I mean, I can complain about all day long if you want to. We can spend hours on it, but what are you going to replace it with it is the problem, right? So, so I'm going to delve deeper into the right-hand side over there. Next. Okay, so now we're talking about security. So this is the first step that we have with our customers, the first security issue. How do you get images to them, right? So none of these people are on the cloud. Some of them can pull stuff in, but there's a number of them, especially Asia. Asia gets pretty scary on how air gapped they are. It's basically when I have to help them debug stuff, it's usually they have a cell phone, they take pictures of a screen, and that's all the information I have access to. So, but a lot of what's pretty common is what everyone wants to do really is, so Cloudera makes a build, we publish it on our repos. Then what happens is they have to pull it into their network. How many times it gets copied from there, it differs, but normally they mirror into one place locally in their network. Then they run it through their own CI/CD process for scanning. Right, everyone is scanning for CVEs, then after they've done that, then they'll be willing to publish it to someplace internal to their network, right? Because they don't want to be dependent on anything in the cloud, right? So they want to, because I see the growing trend of they want to be able to cut off the public cloud at any point in time, right? Because yes, they're up 99.999% of the time, but they're actually worried about security reasons and things like that. They want to sometimes arbitrarily cut off things from the cloud. So and eventually they just basically mirror our repo internally to their clusters. So getting more detail here. So if you are familiar with Cloudera, this is with CM and our private cloud base. So now this is containerized. This is normally bare metal, pretty much always bare metal. Once in a blue moon, you'll see this in a VM or something like that, but this is pretty much always bare metal. There's no reason not to be bare metal. But for this, what we're talking about here, this is only here for storage reasons. So there's storage, and actually, I'm sorry, the other thing that's in this base cluster are the things that we saw in the previous slides related to security, as in lineage, ranger policies for security, things like that. So we start off with that, what customers already know, they already understand. And then we add this other cluster, this ECS cluster, and it's added actually the same exact way as the existing CDP cluster is added. So once again, as CM, basically they just provide a node, something we have SSH access to at least. Actually, not necessarily always. What happens is there's that thing, a CM agent on each of their hosts. What happens is they provide a host, that CM agent somehow is on there. Sometimes it's installed with Puppet. Sometimes they let our CM install it, but there's a bunch of different ways it can get installed. So basically that CM agent gets on there. And then from that tool, that piece of software running on there, then we can actually deploy our own software on each of these nodes. And so for that, we are using, actually, I'm not sure how far deep into that I can go. So we're using RKE2 here. Right? we're doing RKE2 here. And so we found that to be very useful here because that works on multiple OSs. Basically, all of our customers are very strict on what version of OS they're running. They don't. We've been trying to force them to other OSs recently, but they really do not want to take up an opinion on it. They have their own decision and they're just going with that. So we deploy a parcel. The parcel is, if you're not familiar with Cloudera Manager, parcel is basically a software distribution mechanism that's been part of Cloudera Manager for more than 6 or 7 years, long before containers. And that gets our initial bit of software on each of these nodes. That includes the Kubernetes distribution and also a number of Helm charts, which are specific to this piece of software. Because mind you, on all of this, there's no hyperscaler at this point. There's actually there never will be any hyperscaler in here because we're we solve the air gap problem first. If you solve the air gap problem, then you solve everyone's problem. This is basically the rule here. And once that cluster is deployed, and so this is where it starts looking again like what's in public cloud. You have actually a single namespace for all these various, I will call them microservices, depending on your point of view. Some you may not consider it a microservice, maybe you do call it a microservice, but there's actually over 100 of those guys sitting in there. And the deployment of that is actually fairly unique to Cloudera. So it's basically, we have a number of charts that different teams build individually. Because each one of those 100, what happens is there's probably about, I have to guess what, more than 15 teams at some point or another that have contributed bits and pieces. And so what happens is we bundle them up with their Helm charts. We make some other on-the-fly modifications to the Helm charts, and then also on the rendered Kubernetes objects, and then we deploy that onto the cluster. And that's just to get that control plane onto the cluster. Right? So that's not even the workload yet. That's just to get the control plane on there. And that is, let's see, what else is there? Yes. And that gets on. And then from there, we can also launch other things as a side, like a vault for storage secrets. We'll also do some other setup for the customer because, again, what they really want is a plug and play sort of thing, which is they know CM, they know Cloudera Manager, they know how to configure things. CM has a very nice data-driven UI as far as, we can add on more parameters whenever we want to, and it gets rendered to config files, things like that. So they're used to tweaking stuff in there, and then there's menu options for a restart and fun things like that. And then so that is getting us our initial cluster, and from there, so this is what a worker node normally looks like. So we try to keep all the other stuff on the control plane. On the worker nodes, we're actually keeping the data services. So we have all different request sizes for clusters. We not only do we support a single node cluster, we also support some of our customers have 70, 80 node clusters at a time. We haven't seen too many really big ones yet, but it's just a matter of time before we start seeing them. And so, yes, so what you would expect on a worker node. And this is a combination eye and memory test. I will flash this up for 5 seconds. You must memorize it. Then I will turn off the screen, and then I will quiz you. Prize is my respect. No, anyway, the reason I show this slide is to demonstrate all the different communication between different pieces of the system is in just a level of complexity. It could be actually a lot. It in reality is about 10x more complicated than this. But this gives some high level. This is actually a slide we created for one of our customers to demonstrate in particular what type of communication is going on in the cluster. Basically, this is a security review team. They wanted to know what certificates were used where, and what ports we're talking about, what was talking to what. And so this was part of the process of, I didn't want to really scare them on how complicated it was, but I wanted to give them a full, a good idea. So what you see is those red lines. Those are between the base cluster, because that's the base cluster on the left there, talking to the workloads, right? So that the workloads tend to talk to those services directly on its own. Then the control plane is talking to multiple things, like the customer has an AD server. In this picture, there is an external vault. We actually now mostly only do internal vault, but in theory, you could do an external vault. We just don't want to support that right now. And then, just a lot of random connections. Okay, so challenges. I thought this is interesting. So this is actually things that a lot of people in Cloudera do not know or understand. How do I know they don't know or understand? I have to tell them over and over and over again. So security. So CVEs are not the #1 concern of customers. They are important. It's a threat factor. It's very important. It's just not the number one on their list. And I think a number of people forget that that's the issue. Their biggest issue tends to be their own employees. That's one of the things I actually liked about the show, Mr. Robot. If you saw it years ago, they highlighted the fact that it's not some random hacker with some special software hacking into your system or something like that. That's not reality. That's just a TV show. What happens is you hack the people in the company. If you're going through your training, right, they talk about your social media presence, like your passwords and things like that. If you're going through any of that type of training, that's because, the employees are the biggest leak. So what happens is all different banks and customers, they spend a lot of energy coming up with their own policies on how do they secure things. And so that's when you get one bank has this set of policies, this other bank has another set of policies, other bank has another set of policies. We'll also forget about the fact that some of them don't know what the container is. That is a good, and maybe 1 out of 10 customers, I have to explain what a container is and how that works. But when they do understand, they'll come up with their own type of image scan requirements. So yes, they want the critical CVs. That's easy. But they also want a few other things. Like for instance, no images with root. I want your images to be read-only file system. Basically, a bunch of random things. All of them actually in reality legitimate, right? They're not like crazy requirements, but when you add them all up and they're all doing different things, it becomes pretty painful. And also Cloudera, we do try to leverage third-party open source stuff. And so that becomes extremely difficult if there's some third-party software that's not following that. Also, the host level runtime, like I was talking about, they have their own OSs. Another major issue we run into that is the security tools. So there's a lot of security tools out there that try to dynamically learn their workload, right? And any change of behavior, they consider a problem. So they'll kill that new behavior. That's quite annoying, especially for me because what they'll do is they'll just drop the packet, or they'll give an innocuous error, like just basically access denied or something like that. But you have to find out, you have to tell the customer, why is it not working? Because why am I getting my 404 error code in my UI? It's because your software randomly decided in between these two pods, all other nodes are fine, all other communication is fine. It's just this pod and this pod cannot talk to each other anymore. So fun times like that. Also, more challenges. So since we are air gapped, so the customers that do allow you to upload DI bundles, they, of course, they don't like the idea of something like a Datadog or something along those lines. So those guys are awesome. I love you can just stream logs to their server. It's indexed, and then you can search through it and get stuff. But no. There are a number of people with security concerns who will not want to do that. So yeah, people are also trained on the concept of, if an error message comes up, you should be able to figure out like what line of code that goes back to, right? I mean, there's a lot of people who still think in that format. I mean, that's how I grew up, but that does not happen in Kubernetes, right? It's abstraction layer after abstraction layer after abstraction layer after abstraction layer. So you really don't know. You really do have to search through log files for it. Anything else? So I think it was my last slide. Yes. Okay. Questions? Or is your mind exploding? Yes. So to repeat the question, what do we do to connect the customer's account with the Cloudera?
Yeah, one of the slides showed the connection between the two accounts.
So in the air gap scenario, which I'm mostly talking about here, there is CM has a license, the Cloudera has a license, and what happens is that license indexes through Salesforce, and and we include that in the diagnostic bundles and things like that.
I think it was a few. Yeah. AWS account.
Yeah. Yes. And so what happens in the public cloud area when they do is they enter in their AWS credentials into basically the Cloudera UI and then what happens, those credentials get reused to generate the workload clusters like that.
But do you know if it's a transit gateway or some sort of VPC peering?
What's that? I'm sorry, I didn't hear that question.
So do you use a transit gateway between the two accounts in that case that Rahul mentioned? Then they have to connect to the two AWS accounts?
No, it's a direct.
Okay, awesome. I also, do you mind explaining the base cluster and the second cluster that gets provisioned?
So the base cluster is, best way to think of it is, so when you're in the cloud, right? So when you're in the cloud, you normally have things like RDS service for database. You have S3 for storage. You may have other services in when you're in the cloud. But so that's one thing. That's the primary thing is storage, because it's once again, this is all air gap. There is no S3 or ABFS, FS. None of those things are available to you. So they need storage internally. So that tends to be for private cloud, either HDFS or Ozone. And it also has, so Atlas is lineage. Like if you make a change of data, it's tracking data changes. Ranger is policy management. Like for instance, user so-and-so has access to these tables, that sort of thing. So that's all those sort of things are in the base cluster. Basically, it's the storage part. And the ECS I've been describing is more of compute.
Okay, I see. Thank you.
Yes. What did you mean by hyperscalers? You said
Hyperscalers would be AWS, Azure, Google Cloud. I mean, those are three hyperscalers out there. Right? And they all solve the same problem in different ways, right? They have a whole bunch of hardware, and they provide a number of services. And so that's a big difference between on-prem, because at least when you're in the cloud, right, S3 means that's going to be there until there's World War III, and then it's still probably there at that point. So basically, there's no way Cloudera or the customer can screw that up. Whereas here, it's HDFS, so there's ways the customers can screw that up. There's ways that we can screw that up. So it's a different philosophy in handling data, and who has access to what assumptions you can make is actually the biggest difference.
Back in the beginning, you mentioned splitting, which makes the rest of this possible. Compute and storage. Traditionally, back in the Stone Ages, they were kept together because of
Data locality.
Right.
Data locality, yeah.
Just keep everything together. The storage is there, but now you're having to move bits around in order to do the compute on them. What kinds of inefficiency do you find from that?
So one thing with the data warehouse, so what happens is caching is the big answer there. Right? It depends on what the application is and what it's doing, but it's all going to boil down to caching. So, the compute versus storage, that debate has been going on for decades, right? It's prehistoric, right? So it depends on the application, how you do the separation. Because if you have a true compute, then probably what happens is your storage has too much compute on its side, it's being wasted, right? And then you run into the problems that you're talking about. Then you want to hyper-conversion again. It actually cycles back and forth of separation is good, separation is bad, separation is good. Yeah.
Once they get more.
white plastic.
Yeah. Yeah, I would say it's also application specific. Some things it's much easier to keep it separate. I would think in general, as things move into cloud, so if most things you do really want, you're just defining the workload and then say something like S3 is your storage for that. Because then you have guarantees of S3 storage connectivity to whatever your compute is. So it depends on what the application is, right? That's all.
Cool. Thanks.
Okay.
Any other questions?
All right. Thank you.
This is the last talk of the night, and what's stopping you from eating cold pizza leftovers is watching my demo. So I'll try to keep it quick. Thankfully, Anusha did a lot of prep work for me. She called out all the pain points. If you don't have 500 smart coworkers like Anusha to build IKSM, or you think your coworkers are dumb, or you have you don't have a large team, then you should think about multi-cluster schedulers. So we've been used to treating clusters as pets. I was recently educated by a prospect that talking about pets and cattle is not politically correct anymore. So until we find better terms, and this is speaking as a vegetarian, I have no skin in the game, bear with me if I refer to clusters as pets instead of snowflakes, a matter of habit. So we've been used to treating clusters as pets because we have traditionally thought of our large VMware clusters or large Mesosphere clusters, and we have these large size clusters, but small number of clusters in our production environments, in our staging, in our dev. But fundamentally, when we switch to Kubernetes, we've been thinking about having a large number of small clusters. So that's the paradigm change that happened from VMware to Mesosphere to OpenStack. Didn't really survive for that long, but moving on to Kubernetes. So we are thinking about having large number of smaller clusters. So thinking of clusters as special snowflakes is no longer feasible for management, and both from a DevOps time and compute cost, as well as the resource utilization point of view. So pretty soon we end up with this graveyard of idle clusters. So let's say you have this trial environments that you're trying to provision for your internal or external customers. You have this a trial cluster that someone in your team provisioned, used it, and there's this idle orphaned control plane lying around and nobody wants to touch it because you don't know why it was provisioned, who provisioned it. So you have this graveyard of control planes lying around. Or you might have used a cluster for running some machine learning workload that had ran a job that was bursty in nature, and the job scaled down, and you have this control plane and you don't want to touch it again because you don't know what it was used for. And Anusha covered most of the pain points of why this is a DevOps time overhead. Thank you, Anusha, for covering the upgrade use case and keeping the config drift from the homogeneous set of clusters that were provisioned. You don't want their CNI, CSI versions or the AMI versions to be drifting too much, or the security patches that you've upgraded to be drifting too much. By the way, I'll share the slides on the meetup page later, so you'll have a copy of everything. So let me cover things that weren't covered by Anusha, which is nowadays everybody is, whether you were an ML company or not, you have these GPU use cases that need GPU devices, and all GPU devices are not available on all regions, on all cloud providers. So, you're also very particular about, hey, for my algorithm, ML algorithm X, I know that these GPU shapes are really useful, and I don't like these GPU shapes for performance reasons. So you want your applications to be run on the cloud cloud region on the clusters where the GPU device is available, GPU shape is available for your ML workload. So that is another use case where you might want to be picky about picking a certain cluster in a certain region where the shape is available. So all of these problems point us to something, pointing us in one direction. The direction is what we have arrived at when we arrived at building control planes for running containerized workloads or even virtual machine workloads. So think about the days when we were running monolithic apps on these individual large server blades, and why did we need a centralized control plane? Because managing these individual server blades became too much to manage at scale, and that's how we got our virtual centers in the VMware world. We got our Mesosphere marathons, and we got to Kubernetes. So we are arriving at the same set of problems that we've already solved for at a single Kubernetes cluster level, and we are trying to solve them for the fleet of multiple Kubernetes clusters. So it's time to start thinking about your fleet of clusters as commodities instead of special snowflakes. And we want to be able to run multiple applications without managing your individual clusters. So what does the future look like? Future looks like having a supercluster, which is a federated Kubernetes cluster that is managing your workload clusters in multiple regions on multiple cloud providers. And the end user, your end customer, whether it's your internal GitOps workflows or your command line user, is talking to this supercluster control plane. And the DevOps engineer is going to define the policies that will determine where your app needs to get scheduled to. So the end user shouldn't be exposed to where your Kubernetes control plane is running and what kind of compute nodes and compute shapes are being provisioned by the underlying fleet of Kubernetes clusters. So there's several products in this ecosystem. Red Hat has OCM, Rancher Fleet, Armada, and Cloudera folks have been talking about Armada. And the cool engineers at Laurel have also built a product called Nova. Half of them are here, Selvi, Shivani, and they did the work. I do the talking. So yeah, they're the cool kids. So for the purpose of the demo, I'm going to use Nova, but the same principles and the same concepts apply to all of the federated Kubernetes schedulers. So you can replace Nova with any of these, the other schedulers, and you should get the same user experience. So all federated Kubernetes schedulers they use policy-based placement of your workloads onto multiple clusters. And the underlying scheduling happens automatically based on the user-defined policies. So Anusha talked about using GitOps principles. If you're not using GitOps, you should consider using GitOps for scheduling your workload. So whether it's a GitOps that's driving your creation of the application or the end user running kubectl, the application is being scheduled using either of these two workflows. And the DevOps person is defining the policies as to where the application should land or what kind of resources the app needs. And I'll context switch into demo pretty soon, which will make this a bit clearer. So these two things are coming independently into your supercluster, and the supercluster is going to schedule the application to the right cluster on the right cloud provider in the right region based on the DevOps engineers defined schedule policies. So this kind of abstracts away your fleet of Kubernetes clusters from the policies that the DevOps team still has control over. So it also simplifies your GitOps operations because you don't have to list your fleet of 312 clusters or how many other clusters you have as the end target for your GitOps workflows. Instead, your GitOps workflows will point to the single supercluster endpoint that is going to be the target for all of your applications, and the app will be directed to the right workload cluster. So what is a schedule policy? Schedule policy abstracts out what are the Kubernetes resources the schedule policy needs to be applied to, and what are the target clusters that are suitable candidates for the placement of this of the objects that are being selected by the schedule policy. Let's transition to the terminal screen to see an example. So can people at the back see Robinhood? uh, okay, so here we have two kind workload clusters. And Nova is the scheduler. Nova is a super cluster controller that is managing these two kind workload clusters. And let's look at a sample schedule policy. So this is a simple schedule policy. What it is saying is, hey, schedule policy, please select all objects that are entering the supercluster with this label set. The label is Kubernetes metadata name set to guest book. And within this namespace, sorry, that was the namespace. Within the namespace, select all objects which match app set to Redis and app set to guest book. So once these objects are selected, the second component of the schedule policy specifies what is the target cluster that these objects need to be scheduled to. So very basic scheduling policy could be a one-to-one, where you say, hey, I want all of my workloads to be scheduled to kind workload 2, for example. So let's first create the schedule policy. So once this policy is created, let's look at a sample guest book app. This is the standard Kubernetes guest book app that's available on the Kubernetes GitHub site. So this one has the app set to Redis and app set to guest book as well. The two components. Here you go, the app set to guest book. So let's go ahead and create this guest book all-in-one. It needs to be in guest book namespace. Before I do that, let me start watching all the deployments in both the kind workload clusters. Are the bottom window font sizes okay, Robinhood? So what we're expecting to see is Nova should have looked at the, oh, sorry, I need to select guest book namespace. Here you go. So Nova scheduled the guest book stack to our kind workload cluster 2 because we asked the schedule policy to schedule it to kind workload cluster 2. So we see that all 3 out of 3 of front end, 2 out of 2 of Redis follower and Redis leader up. So let's go ahead and change the policy to target kind workload 1. So I'm editing this policy YAML. Then I will do a kubectl apply. See. So we see that the guest book stack migrated from kind workload 2 to kind workload 1. So it's a programmatic way of specifying what is the target. And this is the simplest step 1 where you're actually calling out and naming the target cluster. Does this make sense? Cool. Let's go ahead and delete delete guest book and delete the policy as well. So There are other more complex policies. For example, you can spread workloads. So you could say that I want 20% of my my workloads replicas to go to kind workload 1 and 80% to go to kind workload 2. So this could be useful in application upgrades, for example, on your inserting into your GitOps pipelines. And some of the concerns that were raised during cluster upgrade workflows as well can be slowly migrate traffic over. So not just migrating your network traffic in the north of your application, but actually spreading your apps from 20%, 80%, and then slowly transitioning your apps entirely to the new upgraded cluster. So let's go ahead and create the schedule policy and watch. Then we'll create an Nginx app that will that matches this policy. So what we want to see, what we are expecting to see, is that the percentage split that was called out in the policy reflects in the way Nginx deployments replicas are split between the two clusters. So while this is coming up, we see that there are 8 replicas that are scheduled to kind workload 2 and 2 replicas that are scheduled to kind workload 1. And the replicas should start coming up pretty soon. Yeah, we got 8 out of 8 and 2 out of 2 here. So let's go ahead and try to do something interesting. Let's try to scale this deployment. And set the replicas to 20. So we're going up from 10 to 20. So we should see that the 10 new replicas are again split in 20/80 split between the 2 kind workload clusters. So we see that 16, it jumped from 8 to 16, and this jumped from 2 to 4 here. Does that make sense? Cool. So these are 2 basic simple scheduling policies, but there are a lot more powerful constructs that can be specified using the schedule policies. One interesting schedule policy is availability-based scheduling. For example, if your app needs a certain, it's an ML application and it needs a certain GPU shape, you can say that, hey, schedule policy, pick a cluster in a cloud provider in a region that has available resources needed for this application. So the available resources could be a GPU or CPU or memory or whatever resources you want. Nova would be smart enough to ship your application to the right cluster in the right region on the right cloud provider that satisfies the resource requirements for the application. There are also schedule policies that let you replicate. For example, you might have your logging, monitoring, analytics stack components like your Prometheus, your Fluentd, and you want to make sure that all red clusters are on Fluentd version X. So that's another schedule policy you can use. Or if you want to schedule Istio to all of your blue clusters, but you want to make sure that each of the cluster gets its own bespoke secret. So you can say that, hey, Nova, schedule Istio to all of my blue clusters, but here are the overrides. It's very similar to the customized overrides that Anusha was referring to. So the concepts are the same, but we are bringing it one level above to manage a fleet of clusters using solved techniques that were implemented for a single cluster, if that makes sense. we're not done yet. I know we are over time, but one last thing. So why should we have always on clusters? Anne and others at Cloudera have built just-in-time clusters where you don't even need to have always on control planes. Why should you pay your not so favorite cloud provider money for not running any applications? So just-in-time clusters, basically the clusters come up just in time when a workload needs to run on a certain cloud provider in a certain region, for example, for your machine learning workload. Or you might have something like, you're running your QA jobs and you might want to pick the lowest cost compute shape, and you really don't care if your QA job runs on AWS or GCP as long as it's running using cheapest compute for your 1 vCPU, 1 gig of RAM. So for those kind of scenarios, just-in-time clusters are super useful, and also for bursty workloads where you know that your workloads are not going to need peak capacity all the time. That's another use case. Or if you want to burst to public cloud, you have on-prem data center resources, but you want to burst to public cloud for Black Friday needs or whatever, you don't need to maintain an always-on control plane on the cloud provider. So those are some use cases for just-in-time clusters. If you have any more questions about JIT clusters, please talk to Anne. So takeaways, it's about time to start thinking about your Kubernetes clusters as commodity and not pets. And this is not just for the cases where you have large fleets of clusters. Even if you have 2 or 3 clusters, you want to make sure that your applications have HADR out of the box. Your app moves to a different cluster if a region goes down on a cloud provider. These kind of workflows will be automated if you start thinking about clusters as commodity instead of special Snowflake pets. And why should we waste resources and DevOps time maintaining these fleets of clusters when you can use solve techniques in the Kubernetes ecosystem and just bring it up one level above, if that makes sense? If you want to try Nova, you can use try Nova repo, and you can run the kind workload examples that you just saw. You can read about Nova on the docs website, and also we have a multi-cluster podcast. It's a vendor-neutral community podcast for folks that are power users and power builders of tools in a multi-cluster ecosystem. So if you are a power user or a power builder, want to come on as a guest, please talk to me. Thank you so much. This is the last talk, and super appreciate you supporting us and coming together as a community. Our second talk is going to be at Nutanix at the end of October. We have really cool speakers lined up, so please watch the meetup page for the invite for that as well. And thanks to Sid and Cloudera and everyone else, Anusha for making time, and you all for showing up and listening. I really appreciate it. Questions? You can talk to me later.
How many clusters can Nova manage well?
And well is kind of depends on how many drinks you bought me. We should talk probably. There is. It is something. Yeah, if you want to deploy Nova in production for managing 100 clusters, we'd say please hold off. Let us test it first, but couple up to 50 or 60, maybe we'd feel comfortable. Also, it depends on the number of applications. Like so yes.
That's how it's up to be set for Red Sea.
You're not there yet. So it's something we should definitely consider. Yeah, sorry. The question from Kevin was, do we do any pen testing? So we haven't, but Nova is running the Kubernetes API server. So we are as secure or as insecure as a Kubernetes API server. Selvi, do you have anything to add?
Yeah, we use completely your API server and etcd from the open source community. So changes to
Any other questions?
Yeah, so
Just let
So the question is, how do we work with Service Mesh? So we're not trying to be a compute scheduler, and we work with the tools and the ecosystem. So we've tested with Istio, and what are the other things? So, Linkerd, yeah. So we've tested with Istio and Linkerd, so scheduling it to various workload clusters and making sure the connectivity works and failover works. So we do want to try Cilium Service Mesh at some point. We haven't tried it yet, but any Kubernetes certified networking solution should work technically, but we won't claim that it works until we've tried it ourselves. Does that answer your question, Chris?
yeah, I actually also wonder about things like service discovery, things like that. How does that work?
Yeah. So the question is, how does service discovery work? So the Nova doesn't take care of service discovery. If you have a multi-cluster service discovery component that you want to deploy using Nova, Nova will schedule that, and you can use that for service discovery. Does that make sense?
Well, service discovery Kubernetes DNS. So, and well, it's different logic. It's for DNS. When you discover services that way, I just, if you're managing on top of other clusters, right, then that kind of breaks that model that Kubernetes has as far as service discovery. I just want to know how you, like, for instance, if everything in the local cluster has a particular name, and my particular namespace has a particular name, and so on and so forth. I don't know how does that work with local.
I think after scheduling, get just talking.
Okay.
Yeah.
There are open some projects for and Admiral actually can do service discovery across clusters. So Istio reports back its topology to Admiral. So, but Admiral is also one of those projects that Intuit incubated. So it could be very specific.
Oh, like you said.
Yes, yeah, exactly.
So we saw examples of like simple apps, but what happens when apps have volumes and data?
Yeah, that's a really good question. So once again, Nova is a compute-only scheduler, so we rely on external products and external projects. So if the underlying volume is accessible in a different region where your cluster is, then Nova would be able to pick things up. Or we've seen Percona folks talk about pushing to S3 bucket and pulling from S3 bucket. So either the app needs to take care of state management, or the external third-party product. Like, if Carsten has a product, we'd love to integrate with it. We are very clear in our agenda. We are a compute scheduler, and we want to work with and integrate with networking solutions and storage solutions out in the market, and we don't want to get into that space.
Thank you.
Any other questions? Iran.
Okay, 2 questions. One is, well, first, congrats on the live demo. That's really wonderful because, live demo gods, right? Yes, right? So the first question was related to the scale question. I think Guy had mentioned, and I wanted to know what part of the system's getting loaded. Is it the etcd or like as you scale, right? Like,
correct. Yeah, let Selvi answer that.
We are depending on etcd to store our application state. So our scale limits are restricted by that, but we intend to, move out of it once we can establish the limits.
I'm trying to remember what the second question was. Oh, so the second question was, somebody said, someone from Eloto, I think, said something about that once you guys push the policy or you get out of the way. That's what I heard. So is everything just sort of like one direction, basically, kind of like pushing it out? And then the clusters are doing whatever they've been asked to do and they're waiting for further instruction, or like, I guess my question was kind of
I see.
getting back to maybe what Chris was saying about the service discovery, about there's any back talk, any back communication
For
back
sure,
up
for
to
sure.
say, hey, I've got this here, or
Yeah. That's a really good question. So Nova has two components. There's an agent running on each of these individual clusters, and there's a central control plane, which is your Kubernetes API server, and there is back propagation from each cluster. So Nova has this God's eye view of your fleet of Kubernetes clusters, and that is why it is in a position to make intelligent decisions like high availability or disaster recovery, because it would know that cluster 3 in region Y on GKE is down, or the app on that is down. So it can initiate some of the recovery workflows because it has this God's eye view. So yes, there is it constantly gets updates from each of the workload clusters. So think of it as each of the workload clusters as a kubelet workers in a single Kubernetes cluster, right? Your single Kubernetes cluster control plane is aware of the node health of all of the worker nodes. So it's the exact same concept, but taken one level above. Does that make sense?
Yep.
Yeah.
Thanks.
Sorry to take this longer, but so you mentioned that your supercluster, basically Nova has a God's eye view of all of the deployments in all of the clusters. Is that simple health checks that you monitor for the for your deployments, and then when your health check fails, you basically look at your scheduling policy and move it to a different region? But what if that service truly actually failed because someone wrote crappy code?
So if the service truly failed, so if the single workload cluster is the master of the number of deployments it owns, right? So if the service is constantly failing and getting restarted, it might still show 15 out of 16 or 10 out of 16, but constantly trying to churn there. But if you want Nova to do something smarter, like, hey, this service is failing on this region, on this cluster, then Nova could have health check. It can monitor a Prometheus health check endpoint and reschedule it to a different one.
So does it check or across regions? It's best is standing, does it actually have checks on
Yeah.
The job you write a policy, way to policy is that it.
Then your service also should be running in all these regions so that you know that there is one bad one.
Right.
One or the other.
Sylvie, you want to expand?
So yeah, in our HADR extension, which wasn't covered here, we use a combination of application metrics as well as cluster health metrics to make those decisions, the rescheduling and the reconfiguration of other cloud resources that may be associated with the Kubernetes workload.
Control plane needn't always be on. That's where just in time might come in. If Nova determines that the app needs to be scheduled on in this region and there is no control plane, it might spin up a new control plane. And is that right workflow? Yeah. Is it on?
It's basically best effort. Where you reschedule by the region.
Right, yeah.
But it's best effort.
So one of the frequently asked questions after this demo, you guys haven't asked. So let me ask it on your behalf. Yeah, so one of the questions that gets asked is, what if I have 5 replicas and you have 50-50? What does Nova do? Thank you for not asking that question. The service gets split in half, Ron. Now it'll be 3 and 2.
Hey, Madhuri, awesome demo. I loved absolutely. So I especially loved the 80-20 demo. Like it shows promise for what true multi-cloud hybrid architecture could be like. So obviously, like, this is a critical foundational service That's going to make a lot of things, other things happen. So what do you see as step 2 and 3 other things that need to happen in the ecosystem to make cloud really a commodity? Right now, cloud is so expensive, it's ridiculous. So yeah, what are the other, I guess, like 2 or 3 big blockers to making, getting a EC2 instance at 1 cent per hour instead of 25 cents per hour? When is that going to happen? And what are the other blockers for that?
Yeah, so there's a reason why no one from AWS or Microsoft or GCP is in this room. So let's talk shit. So 2 things. First thing is we need multi-cluster networking and storage projects and products to improve as well. That's where like Carsten and the folks at Cilium and Istio, these things, and service discovery, these are things, because we are for sure looking at building with this framework, but we want the storage and networking experts. So we want that ecosystem needs to mature as well. That's the first thing. And the second thing is tied to Anusha's look ahead slide, where she talked about thinking about defining applications in a higher level construct, where you talk about, here is my app and here is how I want my app to behave. I want HADR for the app, things like that. So right now, these kind of frameworks are quite fragmented. Like Intuit is coming up with your own thing, and hopefully you guys will open source it at some point. But I know that there are other projects that are coming up with their own application manifest definitional language. But if we can have, like, if we can unite on that front and come up with a common language, I think that will help us get to that nirvana stage quicker.
Awesome. So can I ask one last question before we go to Zoom? There are people on Zoom. We should check what questions they have. So what's your prediction on when will the prices of Amazon fall by 10x? EC2. No, not, yeah. Like the compute instances, like what I hear from various industry analysts is because of technologies like this over time, as things get commoditized,
right?
With things with steady state, like the price per CPU in a private data center is going to be the same as public. Right now, there's a 5 times differential. When do you see those two converging?
Yeah, that's a really good question. Actually, Kubernetes is a really good first step in helping us get that way, because right now there's a little bit amount of portability because your Kubernetes control planes are at least standardized. So you can switch from EKS to GKE to other control planes, but you're still tied down with all the scaffolding around your cloud resources. So platforms like this and the networking, multi-cluster, multi-cloud networking and storage solutions. So once these kind of converge to truly commoditizing compute across various cloud providers, then Anne did a few experiments where Oracle's compute was an order of times cheaper than other compute shapes for Kubernetes workloads that were running AI ML. But today, we can't get anybody to try Oracle Cloud, right? So the projects like these will help you automatically consume cloud providers without even having to hire a team of army of Oracle certified Kubernetes engineers, right?
Awesome. Thank you.
Cloud portability and competition. So that's what Madhuri is saying. As the cloud, you can port your applications across clouds more seamlessly, and competition increases, the prices will come down. Yeah, that's Kubernetes is the magic for that.
Thank you. Should we go to Zoom?
Sure.
If there's any questions there?
I don't see any questions on chat.
With that, let's bring this meetup session to a close. Thank you, everybody.